Hi, you guys, and welcome to your lesson all about acceleration. Okay, so acceleration, you've heard this term before, and you know that acceleration means to speed up. And you also have heard deceleration probably, and if acceleration means to speed up, then deceleration must mean to slow down. So, what this looks like in terms of velocity would be your initial velocity meaning that's where you start, has to be less than your final velocity, where you wind up. So if you start off slow and you end up greater, right, you know you've sped up. So when an object's change in velocity and acceleration have positive values, you know you're accelerating. This is an increase in velocity over time. A car is speeding up. Opposite of that would be deceleration when we're slowing down. That's when your initial velocity is greater than where you wound up. So if we're starting off going really fast and we slow down, your initial velocity is greater than when you stopped, when you ended. Okay, so that's when an object's change in velocity and acceleration have negative values. A decrease in velocity over time, a car is slowing down. What this looks like in terms of a formula would be up here at the top. Your final velocity, so where you wound up, minus where you started, okay, over or divided by time. So let's look at this in terms of a problem you might see. Suppose you're moving in a car that is moving at this velocity, 13.4 meters per second west. Then the driver slams on the brakes to stop for a family of ducks crossing the street. It takes 1.5 seconds to stop. Okay, so then we have to determine what is the average acceleration of the car. Remember to use that formula of final velocity minus the initial velocity. And I'm going to put that formula right up here at the top. So we've got final velocity minus the initial, that's an I, velocity, over time. Okay, so if we know that our final velocity, because we have stopped, if we're stopped, our final velocity is 0, right? 0 minus our starting velocity. We were moving at 13.4 meters per second. And it told us that we reached that final velocity of 0 in 1.5 seconds. That's our time. So now all we have to do is we have to take our calculator and plug in these numbers. So we have 0 minus 13.4. Guys, you know this. That's going to leave you with negative 13.4 over 1.5 divided by 1.5. It is going to take, or their acceleration, right, equals negative 8.9. 3, and that 3 is repeating. Negative 8.93 repeating is the acceleration. A equals negative 8.93 repeating. Now, if it's a negative acceleration, does that mean it's speeding up or slowing down? Slowing down, which means it's not really an acceleration, but a deceleration, because it's got a negative number there. Deceleration. All right, that would just be one example that you guys might see when solving for acceleration, okay? And remember, this is the formula we use. Final velocity, which was 0, because we knew that it stopped. The initial velocity was 13.4. And it took 1.5 seconds to stop. All of this information you get for your formula can be found in the problem, okay? Every single time. So you just do your 0 minus 13.4 divided by 1.5, and you come up with your acceleration. Remember, if it's a negative acceleration, It is slowing down. It's actually a deceleration. All right, guys, if you have any questions, please just let me know. Thanks.